Nano fam, welcome back to another stream. And I'm surprised that we have viewers today because it's Halloween. I thought you guys would be at Halloween parties. I guess some of you are. Me, I'm not. I have little children. I can't leave the house. So I thought a good day to work on Nano. So hello Wenderson. Wenderson says Nano is the light. Yeah, hello Johnny, hello Pies, hello Sergio. Hello, good afternoon, everyone. Yeah. So, today, we are going to do something different than last time. Hey, Sammy D. Oh, it's okay. I have to put you all on the spinner wheel. I have a new spinner wheel. I'm trying a new one. I hope this one isn't rigged. So, where is the accounts? The address book. Yeah. So we have Sammy D. We have Amadeus. Happy Halloween to all, says Amadeus. Yeah, happy Halloween to all. Oh, Ely Bob. So many people in the chat. Even though it's Halloween. That's did I have to have oh Sergio, I don't have you on the wheel. Guys, have I forgotten anyone? I hope not. If I've forgotten you, please just send another message in chat. And we have to start the Bitcoin block timer. Okay, so in 10 minutes. Halloween. Yeah, so in 10 minutes we send out 1 nano. And so here, let's just pick nicer colors here. And background, let's make the background darker and the text like that. Yeah, looks good. All right. Yeah, so what are we going to do today? In the last stream I said I wouldn't I'm only working on the stream stuff on stream and I'm not touching it off stream, and I have to admit, guys, I cheated. I worked on the stream stuff off stream because I wanted to find out why the async message deserializer didn't work in the stream. And then I was so in the flow that I just finished it all. I'm so sorry, chat. I'm so sorry I finished it. So what I did is I refactored all the places that worked with the message deserializer. And they all use the async message deserializer now, and I completely deleted the old message deserializer. So that's something that I had planned to work on stream, but yeah, I'm sorry. I'm really sorry, chat. I finished it off stream. So that means this huge callback function we wanted to delete, this one. It doesn't exist anymore. So I deleted this callback function. I deleted the read query. And now we just have an async message deserializer that works with the socket more or less directly. And we can go on here. But for today, I thought I wanted to work on something new. Maybe that's more interesting. And it fits really well with what our developer meeting was about today. Today in our Twitter dev space, we talked again about message deserialization and how we could improve the performance. And again, we talked about how cool it would be if the messages were not heap allocated. And that is what we are going to do today. So I talked about this in the last stream. So there we drew this diagram here. So what you see on the left side is how it is currently implemented. And I said I was unhappy with this structure and I would like to refactor it into this structure where I have a stronger separation between message and payload. And And yeah, and today we are going to refactor the message. Message is currently a trait in Rust, and in the C++ node, it is a class, a base class. And what I want to do is I want to change it into an enum type. And with an enum type, the size of the message type is known, and that means we can stack allocate it. And stack allocation is just a lot faster. And yeah, and we can use the match statement, the powerful match statement that Rust has. So that's the plan. What do you guys think? That's the plan for today. So we are going to work on the message. I think this is a really good example of how we can do a big refactoring in very small and safe steps, because that's the way I like to work. And I think this is yeah, a way better way to work than with huge big changes that are so tempting to make. For example, now with this change we are going to make, let me open up them, or do I have it open yet already? Let's go to, yeah, to here. So this is the file with the message trait. So this is how it is in RS Nano in Rust, and it looks more or less similar in the C++ code base. And we have the trait message, and we have many implementations of the trait. So you see all of these message types up here as module imports, and we have bulk pull, frontier request, telemetry, and so on. So many message types, and they all implement the message trait. And so the tempting thing to do here is to just change this message trait into an enum, and then to have many compiler errors, and then to go after each of these compiler errors until the thing compiles again. And that's just a horrible way to work here, because this is a huge change, and message is being used everywhere in many places. So if we would do it like that, we would not be able to compile and to run the tests for many hours and maybe even days. And you don't want to be in that situation, that you can't compile your project for days, and you just have to work and hope that you don't break stuff. So we won't do it like that. So what we are going to do is we are going to refactor the message trait into an enum in very small steps, and we are going to keep the project compilable, and we are going to run the tests so that we don't take the risk of such a huge change. So, but how can we do that? So let's see. Let's see how can we do that. So I want to start with a simple, just with one instance, with one variant of message, with a simple one, and I want to start there. So a simple one would be keep alive, maybe. How does keep alive, the keep alive message look? Yeah, keep alive is really simple. It just has 8 peers that it can contain. So this is a really simple message. I think we can start there. Yeah, that's the whole message here. And it has peers, set peers, from stream. Oh, this I also wanted to refactor. Maybe let's do that refactoring quickly, because this is how it was in the C++ code base. So there was a constructor with a stream, and there was also a deserialize function that would just override the fields of the message with the deserialized values. And I don't think we need both. So what I want to have is just a single deserialize function that returns the message or a result message. And I think this deserialize function here is not being used except for in one place, and that is the constructor that this one, the from stream, is like a constructor that constructs the message from the stream. So let's inline that and let's call this function deserialize then. So let's inline this function. Let's delete the old deserialize. And I don't know why this inline refactoring does it with this strange ref mute this, so we don't want that. We want it's just simply like that. So the header type has to be keep alive. That's right. Let's move this debug assert on to the top. So header message type should be keep alive. Then we construct empty pairs. What is empty pairs? Oh, just an empty array. So let's say let mute pairs is empty pairs. Oh, already the first giveaway. That was quick. Let me just finish that so we can inline that one. Oh, that didn't work. I want to inline that one. Yeah, much simpler, and this should be pairs, just pairs. Just a little bit simpler before we start with the refactoring that I actually wanted to do. Okay, no more people in chat? Nope. So let's go. So this is the new wheel. It is not rigged. I hope so. Johnny! Yeah, it is you, Johnny. Congratulations for winning one Nano. Johnny, one Nano. Here you go. Oh, I don't have enough Nano. Oh, I think I just have to receive the Nanos that I just sent here. Haven't received them. Let's try again. Johnny. One Nano. Yep. Congratulations. So this time I won't forget to restart the timer. Yeah. All right. So that was just a very quick refactoring to begin with. And oh, hi Newsh. Let's also put you on the wheel. How can I edit wheel? Here. All right, that worked. Okay, so we have the keep alive message, and we wanted to turn this into a message enum. And the way I want to work here is, let's sketch this out. I want to work like, yeah, so let's see. So this is the current design. We have the message trait, and we have different message types. And I also want to add the keep alive message here, keep alive message here. And so what I want to do is I want to split the keep alive message into two parts. I want to split it into the payload part and the message part. So I want to create a new struct, and maybe we call that keep alive payload. And then I want to move all of the data, which is in the keep alive case, it is just the sockets, the 8 socket addresses, into the payload struct. And then I want to rename the keep alive message into message enum for now, because we can't call it message because message is already the name of the trait. And then we have the split here, and then one by one, very slowly, I want to move the other message types into this message enum. And so we can do it in small, safe, simple steps. All right. Does that make sense, chat? If you have questions or ideas, so please let me know. Please let me know. So this is what I want to do. I want to extract the payload struct. So I want to say keep alive payload, and it will just have the peers. Cryptic, hey, welcome back. Tuning in. Hey, how are you? Cryptic, I think you are also in the address book. Are you in the address book already? Yes, you are. Where can I edit? Why does it scroll to the bottom? Cryptic. Yeah, so keep alive payload. So this struct, I want to use this struct instead of the peers. I want to have the payload, which is yeah, let's do it in small steps. Let's just say it is the keep alive payload. And now let's just find all. Oh, okay, now we have. Yeah, we can do this in one go because this is not that many changes. So let's remove the peers. And this has to also implement clone partial equal debug. And here this is now yeah, so this here empty peers. So I think it should implement default. Should it? I'm not sure, but let's do that for now. We can remove that later. Implement default, and here we just say empty peers. Yeah, let's just say empty peers. Self and peers is empty peers. Like that. And then we here can say payload is default. And what is that? With peers. Okay, so this is now payload. Keep alive payload with the peers like that. With header, so this is again default. Oop. Payload. And now, yeah, so these functions here. Yeah, let's go in small steps. Let's just delegate them to the payload peers. All right. And also here, let's also say payload. Payload is keep alive payload. And these are peers. One arrow left. Display for keep alive. Payload peers. So that was the first step. chat. We have extracted the keep alive payload, and we are good to go again. So this is what I mean in small and simple steps. So that first step, we are done with it, and the project is compilable again. So let's go to the next step. And the next step would be to not just have payload as a keep alive payload, but we should have this as an enum type. Is this the next step? Let me think. Maybe before we do that, we should remove. Maybe we should remove the set peers, get peers, because this is now on the message level, and we should not access the peers on the message level. We want to use the payload for that. So, and especially set peers, I don't like it. I want this data to be immutable. So there's no reason to change a message that exists already. So who uses the set peers? An FFI function. Oh, that means it is in C++. And in this test here, okay, so this test we can easily change. Let's have a look at what the C++ code does with set peers. So the FFI function for the C++ part is called rsn message keep alive set peers. So let's just do a full text search for rsn message keep alive set peers. And we have only one usage, and that is... So now we are in the C++ code base. And this is the keep alive message in the C++ code base. Who calls set peers in the C++ code base? Oh, so many. Four usages. We have one here in the send keep alive. Okay. I don't want to change that. I want to go in small steps. So let's go back. I don't want to change that. So let's keep this set peers function. Let's keep it for now, and I'm going to remove it in the future. The future me, will do this. So okay. Let's keep it then. But maybe we can move it. Maybe we can move this out of our keep alive struct. Again, let's find the usages. So this is just... Oh, another giveaway. Congratulations too. Oh, Cryptic, that was close. It's Nyush. It's Nyush. Congratulations. Nyush. That was close. That was close. Sergio says congrats. Yeah, so here we are in the set peers. So here we have the peers, and then here we do a downcast of the message, blah, blah, blah. We set peers. So maybe we can just say payload is private. Payload is private. So let's make payload public. Why not? Let's make payload public. And you're just happy. Cannot find... Oh, what did I do there? I inserted a character here. I didn't want to do that. So, okay, so we just access the payload directly for now. And who else uses the peers, the set peers function? just this test. And in this test, we can also just go to the payload and say peers is equal to peers. Oops. Yeah. Yeah. So now no one should use this function anymore, and we can safely remove it. So let's go to the next one. This loading of the peers. Who uses that? Okay, also an FFI function. And here we just do the same. We go to payload.peers. And if you notice, chat, like all of the changes we do, they don't break stuff. So we can, after every little step, we could just compile and run the tests or commit to GitHub and do something else. And that is my preferred way of working. And I think this is a really good way to change software in these really small and safe steps where you can just stop at any time that you like. So peers, yeah, peers, who uses peers. We have here in the serialize function. So here, let's also go to payload.peers. Like that. And the last usage is in a test again. So here we want to clone the peers. So we also say payload.peers.clone. I forgot, chat, I forgot the Bitcoin timer. I forgot the Bitcoin block timer. Start again. Yeah, now it runs. Okay. So I think that's it with the peers function. Yeah, no more usages. And let's delete it. So now we just have this function that deserializes the message, and I want to rename it to deserialize. I don't want to rename it from stream. I want to call it deserialize. So it takes a message header and a stream and it returns result self. So what can be the next step now? What could be the next step? We have to move some more stuff to the payloads struct. We have to, let's see, we have to move. So this is the deserialization. So the peers deserialization has to go into the payload struct. So that means that we have to say let payload. So this is the payload. So this part that I'm marking here. So this part has to go into the payload struct. Maybe I'm just, yeah, let's just copy this function and let's paste it into the payload. So import keep alive payload. Oh. No, okay, now looks better. So this now takes the header and a stream and it returns result self. And so it should return not the header and stuff, but just okay. 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 And we can shorten this, we can just say self. And we should be fine again. Yeah. No more errors in here, so let's use our move deserialize function in the message deserialize down there. So here we can just say let payload is equal to keep alive payload deserialize. And it takes the header and the stream. Like that. Mismatch types, expected payload give. Okay, so this is a result. Okay, so we have to do an early return in the error case here. And everything is good again. Yeah, so the next function down there, the serialized size. This also should come from the payload. So let's just copy that function, move it up to the payload. And then let's call our the function that we just copied, let's just call it down there. So self. Oh. This is a static function. Yeah, then let's just say keep-alive payload.serialized size. We have to think about this later. So this, yeah, doesn't make sense right now. Message, implement message, we have header, set header, blah, 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 and serialize. So again, the serialization part of the header, that's okay, that belongs in here, but the serialization of the payload does not belong in here. I want to move that to the payload struct. So also let's copy that. Let's go up to the payload struct and let's paste it here. And we remove the header serialization because that's not part of the payload. And we access the peers here. We write the bytes to the stream and we return OK. So let's use this serialization, this new serialization function down here. And let's say self.payload.serialize stream. Like that. Yeah, that's it. Oh, and the message type. The message type. Message type. That is. I don't even think we won't need that function in the future. Returns the message type. Shouldn't this return the message type from the header? Because the header is also message type keep alive. Can we just, I think we can just say self.header message type. Yeah. And the last, so this is the last part. This is this impl display for keep alive. So here we have to, so displaying the header here is fine. And this part here is displaying the payload. So let's also copy that display implementation and paste it here in for our payload, our new payload struct. So impl display for keep alive payload. And we don't display the header, we just display the peers. And then we call that in the down there in the original function, we say self.payload format. And we are done. We are done again. So this is now looking closer to what I want it to look like. So now we have all of the code that works with our payload in the payload, in the keep alive payload struct. And yeah, so we have this now. We have the, so this is still called keep alive. So we have the keep alive struct. It delegates all of the payload stuff to the keep alive. Let's make it bigger. It delegates all of the payload stuff to the keep alive payload struct. And so the next step now is to rename keep alive into message. Now let's wait with that step for 1 second. Let's just introduce the payload enum in here. So this is now the place where we want to have an enum. So payload. So we have this is an enum then. The payload enum, and for, in the beginning now it will only have one variant, and that is the keep alive. And later this will grow. We will add more and more variants to our payload enum. Yeah. So that's the next step. Let's introduce the enum. Let's introduce the enum. Yeah, so that will look like pub enum payload. Let's just call it payload. And it has only one variant right now, and that is keep alive. And keep alive has the keep alive payload. Oh, that looks a bit weird, doesn't it? So there's the word, there's the name payload, there's the name keep alive, and there's the keep alive payload. Should I? Yeah, let's keep it like that, and later when we ported all messages, we can rename it into maybe just keep alive. Cryptic, congratulations. Oh no, is it news? No, it's cryptic. Congratulations. Cryptic. Or Nano. And restarting the timer. So. Yeah, let's keep it like that. So just an enum with one option. Cryptic says thanks. Yeah, there you go. And payload has one option right now, just to keep alive. So let's use this. So instead of having the payload as a hard-coded keep alive payload, let's change the payload into a payload. And okay, so the payload has to also implement these things. And it has to implement format. Can we derive that? No. I think that these display implementations are just there for debugging purposes, so the format they print is not really important. So we can change that without breaking compatibility, I think. So can we say impl display for payload? And what do we... How do we display? Maybe let's just delegate display to... Can we? I don't know. Can we derive display? I don't think this is possible. No, it doesn't work. Okay. So how to display payload? Can we say match self? Oh, that's annoying. Do I have to duplicate all of that? Is there a simpler way? I don't know. I want to just keep it like that. Just just delegating the display implementation to the actual payload. Yeah. And maybe we find a better solution later. Okay, so now we have an error in serialize. So let's check the errors. So we have an error down there. So default is not implemented for payload. Yeah, so maybe we shouldn't. Can we have default values for message payloads? Who calls this new function? Maybe we can delete this new function. Oh, we can't. We can't. We can't. Okay, so maybe we also delegate the default implementation to... Okay. Now it gets trickier. I don't think there should be a default implementation here. Then let's change this code down there. Then let's not say default. Let's say payload, keep alive, and here we can say default for the payload. Yeah, that's the way. So that is the way. New with peers. So this also creates a keep alive payload, so we can say payload, keep alive. And with header, yeah, let's do it like that. Let's say payload, keep alive. All of these functions, I'm pretty sure I can delete them soon. And deserialize. So here we deserialize the keep alive payload. So here we can also say payload is payload keep alive. Payload. Just one error left. And that error is the serialize. So we have to serialize the payload. So here, let's create a serialize function. And in that serialize function, we just say match. We just match self. And we just delegate to the actual payload. Serialize string. And what's wrong here? Use of moved header value. Yeah, so here we deserialize. Oh yeah, we don't want to move the header, we want to just borrow the header. Oops, we have to borrow the header. We don't want to take ownership. And I think we don't even, do we use the header? Yeah, just for this debug assert. So we need, chat if you're wondering why we need the header here. So the header has some more information, some flags maybe, just some more information about the message. And sometimes we need that extra information when we deserialize the message. It is not the case here in the keep alive payload, but it is the case in other message types. So that's why we have to pass the header into the deserialize function. Okay. So let's just run the tests quickly. Let's just run the tests. Okay, it compiles. Compiles, really slow. Oh no, what is that? We didn't fix all errors. What? Messages? Unknown field? Oh, where do these errors come from? Oh, in the tests. Oh yeah. So request payload. Yeah, so we don't have a peers anymore. So this is the serialization function. Yeah, I want to rewrite those tests because they should go on. They should work with our new payload struct. And it tests the serialization and the deserialization. Yeah, I want to rewrite those tests. They should work with with the payload. So we want to say keep alive payload, and we say peers we want to change the peers, so let's make it mutable, and then we say keep alive peers. So the first peer we set it to a value. Then we serialize the keep alive payload. Or Nano 4. Oh, Sammy, that was close. It's Johnny. Congratulations. So, timer running again. Sammy, no. Yeah, it was close. It was really close. I like that new wheel better because sometimes it's just so close. All right. So yeah, we have the stream, we serialize the keep alive payload, and then we deserialize. Then we deserialized the keep alive payload. And header, we need a header here. But the header really doesn't matter. Deserialized. I'll keep alive. So the mat, we don't use the header. Johnny says, what? Thanks again. Yeah. It is random. This wheel isn't rigged, guys. This wheel is not rigged. Header. We don't use the header. Can we... Yeah, let's just create a header. Message, header. Message header, new. Message header, new. So the message type is keep alive And we need a protocol info. And also the protocol info doesn't matter. Yeah, let's just say default. We have to borrow the header. Yeah. Okay, so there's a couple of tests that we have to adjust here. What is that? Keep alive string. Okay, this tests the display implementation. Yeah, let's also change this test. It should directly work with the keep alive payload. So keep alive is keep alive payload. And we don't need anything here. We can just say default. Then we set the peers. Then we say to string, and we assert that it equals something we expect here. I think that looks good. So let's find all the other problems. So we still have an issue with FFI, keep alive RS. So let's go there. Keep alive in the FFI part. Yeah, so this accesses the peers, but now payload is an enum. So how can we fix this? So we know it is a keep alive message. So let's just assign message first here, message. And now we don't want to access payload.peers, but we have to say let payload equals message.payload, but this is payload keep alive. And else we just panic. Not keep alive. Payload. And yeah. And then we can just say peers is just payload.peers iter map blah blah blah. Yeah. One more, and I think this is the last error here. This is set peers. So same thing when we set the peers. So this is the peers. We set the peers. How can we set the peers? We say payload is keep alive payload. No, it has to be payload. Payload keep alive. And the data structure we pass into it is keep alive payload. With peers. Like that. Looks good. So is this chat, is this am I too fast, or is it okay? So what is that here? Keep alive peers. Message keep alive peers. So this loads the peers from the message. Oh no, we wrote that. And what's wrong here? Consider borrowing. Oh yeah, we want to borrow. We don't want to take ownership. Irrefutable let else pattern. This pattern will always match. Really? Yeah, because we just have one variant? Samedy says, I don't understand half of it, but I still like your stream. Really? Okay. Thanks, man. Yeah, I think I'm a bit too fast today, but I really feel like I like that. I think I should force myself to slow down a bit. Yeah, so to all the new viewers in the stream, what we're working on is we are refactoring messages. So the messages that we send to other nodes and the messages that we receive from other nodes, and we want to use an enum type instead of a trait. And with the enum type, we can stack allocate all messages, and that should speed things up. Johnny says, same for me. I'm here for the music and general good vibe. Oh, by the way, guys, what do you think? What music do you think we should listen to in the stream? I tried different stuff, different streams, and today I just picked a random video because I was in a hurry. Didn't have time to pick something really. I liked the slower one really. Like last stream or the stream before, we had something slower. I like that. So what's wrong here? Why is this always a match? Let payload keep alive. Payload is... Yeah, maybe because there's just one payload type right now. Let's compile and run the tests. And if the tests pass, we commit and push to GitHub. Oh, they don't pass? They don't pass. So the test keep alive string panicked. Okay. Sorry, wrong file. Keep alive panicked. Yeah, because, okay, that is wrong. The expected string expects the header to be serialized, but we changed the test so that it only tests the payload. So that should just be empty string. We don't want to have the header in there. So if you want to take part in the giveaway and you are not on the wheel yet, just post your Nano address in chat. Niyush, it's you. It's you. Congratulations. 1 Nano for you. Niyush, 1 Nano sent. Okay. So tests are green. So let's commit what we did so far. So we split the payload from the keep alive message. Yeah. So we extracted... Oh, you guys can't see that, can you? So we extract payload struct from keep alive message. So that's the commit message, pushing it to GitHub. All right, so we have everything committed. We have a safety net again. So what is the next? What is the... Oh, wrong file. Let's go to the keep alive. What is the next thing to do? The next thing to do is... What is the next thing to do? Payload has serialized, has display. Deserialize, serialize. Yeah, I think now we can rename the keep alive struct into message enum. Because we moved all of the payload stuff out of it. And now it is very generic. Yeah, it doesn't do anything anymore. So let's do that. Let's rename the keep alive struct. Here, let's rename it to message enum. And this here will be our final message enum, where we can now move all other types in. We can move all of the other message types into that now. So we renamed keep alive into message enum. And right now, it can only hold one payload type, and that is the keep alive. So I have to move a window here, and that is the keep alive payload. So should we go to the next message type? Yeah, I think we should, because there's nothing, there is currently nothing we can do here. Just quickly checking the functions we have. So message enum has, yeah, so this here is a bit of a problem. This function is specific to keep alive. Yeah, so we have to remove that function. Let's just add a to-do here. Delete. What else? With header is... Yeah, all of these functions are... I don't think they are... We should really have them. And the deserialize is okay. Is it okay? Does this should match the message type from the header. Yeah, this should match the message type from the header. Like that. Ooh. And let's just, for now, just keep the keep alive in here. And all other types should just unreachable. Or not implemented. Unimplemented. Currently it is only the keep alive message type we deserialize. So say let's that payload. So this should return a payload. And that is the payload keep alive. And then we copy that part over there. So does that make sense? Does that make sense? So payload is we match for the header type, and then we just call the correct payload deserialization. Yeah, I think, and then we can just assign the payload down there. I think this looks correct. But let's run the tests just to be sure. Oh, there's an error here. In which file? Message deserializer impl. Message deserializer impl has an error here. Failed to resolve. Oh, I didn't save the rename. I have to save all files. Yeah, now it looks better. Okay, all tests pass. We are still green. Yeah, so, okay, then let's only fix this here. So this function, we have to delete this because this is specific to keep alive. And we want to keep the message enum generic. So let's find the usages. Okay, just one usage in here, in the struct TCP channels. So message is this thing, peers is that. So, so this wants to construct a message with the peers. So I want this to read like that. It should say message is message enum. So what do I want to pass in? I want to say let's see again, header. Let's make the header public, because then I can just say header. What is header? Message header new. Message header. Oh, maybe we should put that into a function. So the message type, but I want to type it out so that we have a starting point. So the message type is keep alive, and the protocol, we have that here. Protocol info. So we have that here. And the payload. And the payload field. The payload should be message payload. No, payload. Payload. Keep alive. And this should contain the keep alive payload. Oh, this looks messy. But maybe we can clean this up with those peers. All right. Let's check again. Is this correct? So we create a message enum. The header is this thing, and the payload is that thing. So I think this looks good. This looks good. So who gets the 1 nano? Oh, is it? Yeah, no. No, oh, this was so close. This was so close. It's Sammy. It's Sammy. Congratulations. This was really close. One nano for you. Yeah, Sammy. Congratulations. That was so close, Sammy. It was so close. Really lucky with that one. All right. Yeah. This looks good, but I want to extract this into a function that creates keep alive messages for me. Or maybe yeah, let's do that later. I'm not sure where to put that function. I'm not sure where to put that function. Yeah, let's focus on other things first. So back to our keep alive message. So message enum. So let's do one last check before we try to convert the next message. So this new with peers, can we delete it now? Is it unused? Yes, it is unused. So we can delete this function. And it just has this with header. What is this function with header? Can we... No, this was used in FFI. But maybe we can... Yeah, we can maybe delete it here. Yeah, I think we should delete this function and just call the corresponding code in the FFI function here. So create message handle. What does this? Ooh, fn1's message header t. Okay, so here we say message enum. Message enum with header. So here we say message enum. And header is... No, what does this give us? Message header. So this gives us the header here. So header is header. And payload is... Payload keep alive. Keep alive payload is is default. Any errors? Nope. No errors. So that means we can remove this function. Yes, no usages. So let's remove this function. Our message enum is getting simpler and simpler, chat. And that's what I like. That is what I like. Okay. So I think we are good to go to the next message type. But I want to commit after running the tests. Tests are green. So let's commit. Yeah, here we finished. Yeah, so this is finish extraction of keep alive payload. All right. Push to GitHub. So let's go to the next message type. And the next message type is... So this... Let's make stuff we are done with. Let's mark it as green. So we have... This one is green. This one is green. The keep alive payload is green. All of that is done. So let's just pick a new and the next message. Maybe also a simple one. How about publish? I think publish is pretty simple. Publish, publish, publish. Yeah, it just has a block and a digest. Or how about no daddy handshake? Ah, this is more complicated. And here request. Yeah, let's take the publish message because it's also simple. Again, we are going to do the same steps. I want to split publish into publish and into publish payload. So let's introduce this new struct, publish payload. And let me also do this here in the diagram. So the next one is publish. So we work on publish. So let's make that blue because we are working on it. So publish, we split it into publish and publish payload. And we want to have the publish payload as a field. So this will be step 1. And then the next step would be to move this publish payload into our payload enum. And then we can delete this. Yeah, let's do it like that. So publish payload, it should have these two fields, block and digest. And so this, yeah, so instead of these two fields, we should have payload, and payload is a publish payload. So that means down there we say payload is publish payload. With these two values. With header, we also say payload is publish payload. And with these two fields. From stream, oh, the same. From stream, we can do the same refactoring here and just inline the serialize function into there. But I'm just in the middle of another refactoring, so I can't do that. So, but just I want to keep it in mind for later. So here in the serialize function, we say payload is publish payload, and we say block. What about the digest? What about the digest? I'm confused. What about the digest? So here we have the digest, so we have to set. Isn't this part of the serialization and deserialization? We don't deserialize the digest? Is that correct? One Nano 2. Amadeus, congratulations. So block timer running. Where was I? Yeah, so here. When we say publish, we set digest to 0. Maybe this is related to what we talked about today in the dev space. Maybe this could be a reason why duplicated publish messages, maybe they won't get filtered out. What is this digest? I want to find out. So let me just fix all of these errors here. And so I'm going to set it to... No, I'm not going to set it to 0. I'm going to set it to the old value. So self.payload digest. And then we assign this new payload to self. All right, like that. Payload. Where was this? Oh, I just lost where I was. With header from stream. Yeah, no, this one here, this from stream. I worked on this one here with the deserialize from stream. We create the payload, we set the payload. Okay, so what else is wrong here? The trait clone is not satisfied. So we have to, okay, derive clone. So what else? Okay, this is the serialize function. And this is now in the payload. This is impl partial equal for publish. So this is also the payload. And this also is just payload everywhere. Payload everywhere. And the digest. Right. And this is also payload. No, what is B1? Dref? What? What? Block? What is this? No method name dref found for. You have to import dref. Oh yeah, it wasn't. I haven't. Dref wasn't imported anymore. Maybe I was too quick with removing it. All right, 2 errors left. So this is the debug implementation. So this also goes to payload, our new payload field. And this one is the display implementation. It also goes to our new payload field. No more errors. Let's run the tests. No, what's this? Message deserializer impl has a problem. So this is deserialize publish. Yeah, so this is... What is message publish from stream? What is message? It is just publish message, so we can say the payload.block. And we have to make payload public for this to work. Let's also make the header public. And let's run the test. Could not compile. Unknown field. Okay, publish rs in the foreign function interface. So there, publish block. Yeah, so this is also payload. Next error is also payload. And the last error is also payload. So let's run the tests. I think now they should run. Yeah, green. Green, green, green. Green is good. Let's, should we commit again? I like committing, creating commits often and having them small. Yeah, let's do that. Let's commit. So what did we do? We begin splitting off publish message and payload. So all right. We split the payload. We split the payload. All right, so now that we are green, I want to do a quick detour. I want to find out what this digest is about. Because I don't know what it does. So maybe we can find out. Publish digest. So here, is there any usage? So there's a set digest function where we can set the digest, but what is that? With header also sets the digest. With header. Let's go to the C++ code base. And let's find out who uses that set digest. So here is this publish function, publish class of the C++ code base. And it has the set digest here. So who uses that? Tests, I don't care about the tests. No one. Just one test? Just this one test uses this function. What test is it? Duplicate, revert, publish. Duplicate, revert, publish. What does this test do? Add to the blocks filter. Okay, I don't want to spend time here. Just want to see if the production code somehow sets the digest. But I don't see. Maybe here. Create publish handle. Let's go back to the foreign function interface. So here, what is the digest? It is U28. U128, the slice from parts. Okay, so it is. This is the constructor call with the digest. What's the name? rsn message publish create 2. So here. And this creates rs publish create 2. Who calls that? No one. So the digest is always 0, am I right? So this is not being used by anyone, so we can delete this. One Nano for Sergio. We can delete this create publish handle too. No one uses that function anymore. But I don't know why it is in there. What is this digest in the publish message? So Bob, if you are watching, maybe this digest is related to the problem you were working on. If this digest is different for the publish messages, that means the network filter cannot filter out the duplicated publish messages. I think so. I'm going to write something in Slack about this. All right. So what? So let's stop here. So I couldn't find any usages of this digest. Yeah, let's go back. Let's go back to our message stuff. So publish. Okay, so we have publish new, publish with header, publish from stream. Yeah, so now I want to merge these two functions into one. So the from stream and the deserialize, they should be just one function that deserialize the publish message. So this deserialize function, we have two callers. Why do we have two callers? One caller up here, that's okay. And one caller, okay, this is just a test. So we can rewrite the test. Yeah, also this test, I want to change it so that it works with the payload type directly. Because our payload has the... Oh, our payload type has nothing. We have to move the code to the payload type first. So import publish payload. And we have to move this deserialize stuff there. But maybe I change the test first. So that this returns, it should call publish with header. It should say publish to is, it should say publish to is publish from stream. And from stream takes the stream and the header and the digest. Right? Oh, and something else. What else does it take? Oh, the uniquer. We don't have a uniquer. Like that. Let's just run the test quickly to see if everything is still okay. Yeah, everything's still green. Yeah, so now I can merge these two functions into one. I can bring deserialize, I can inline deserialize into the from stream, because this is the only usage. Yeah, so let's inline. Let's inline. And let's delete this old unused deserialize function. All right. So this is asserting that the header type is publish. What does it do then with header? Then it creates the payload like that. The digest is, the old digest is 0, so this is 0. I have to ask Colin what this digest is about. So this returns self. What does it return from stream? Self. Result self. So self header payload. Oops. Or maybe let's do a quick Google search. Maybe we can find documentation about this. Yeah, because digest is not being used. Let's Google. Nano currency publish digest. No, we don't find anything useful. Nothing useful. All right. I want to ask Colin. I forgot to restart the timer. Okay, so the from stream, I want to rename it into deserialize. Deserialize. So now it's a better name. And what else can we move into our new payload struct? Basically, deserialize. Yeah, we have to move this one into the payload struct. These lines. And what is deserialize block? Okay, this is just a helper function. We have to chat this digest. It bothers me. Why is it in there? Yeah, let's just copy that and let's put it into our payload. So header, we take header, we borrow header, we don't want to take ownership. And we return, okay, payload. Oh no, this is the digest. Here we have to put it, but now it makes sense. Okay, can we now call this down there? So we say payload is publish payload. Deserialize stream header digest uniquer. Okay, this is ownership problem. We have to do this first. We have to say that payload Yeah. This looks better. This looks better. Okay. So what next? What next? We have moved the deserialize. Who uses that? Message deserializer impl. Deserialize publish. We are in the message deserializer here. Publish filter, apply. Payload bytes. Here's the digest. Here, this is where it comes from. Okay, so digest is not. This is not being serialized. So this comes from our publish filter. But why do we put it into our message? Why do we put this in our message? But now it makes more sense. So, okay, so this is not serialized. Yeah, because it's just the block. Okay. So this clears things up a lot. So I just want to copy the serialize function also into our payload. So, but without the header. Just like that. Fields has no self.block. What's wrong here? Block option. One of the expressions. No field block on type publish. Oh, but this is okay. This is not here. This is not this problem. It's somewhere down there. No. Publish, serialize. Oh, okay. Sorry, guys. I was in the wrong function. Did I copy it into the payload? No, I forgot. So let's copy the serialize into the payload. Yeah. Johnny says, I'm off. Thank you and good night. All right, Johnny, have a good night. Serialize is... Yeah, so now let's call that serialize in down there. Self.payload serialize. And this is the deserialize. Serialize. All right. Oh, what is that? Is it? Maybe I copied the serialize function twice? Because this is where we should say self.payload.serialize. Did I copy it there? Yeah, so this is maybe wrong. Yeah, I want to run the tests. I'm not sure if I made a mistake there. No, no mistake. Everything's still green. Everything's still green here. By the way, chat. So deserialize. Partial equal. Yeah, so this equals partial equals. I have to copy that also up into the payload struct. And then we can now remove the payload field and the header. And then we can, I think we can auto implement partial equals now. We'll publish. Let's run the test and see. Yeah. Still green. So now we just have to move the other debug and display to our new payload struct. Yeah, Pies, it's you. Congratulations. 1 nano for you. Send instantly. Because that's how quick Nano is. So debug and publish. So let's copy both. Debug and publish to our push payload. So it says debug struct publish payload. It doesn't matter. I don't know where these things are being used. Oh, okay. Debug struct payload. And this is display for publish payload. So this displays the header. Don't have the header, so it just displays the block. All right. And now let's call into these functions from our message. I don't like this. I want to delete this debug implementation, and I want to derive the debug trait. Where's publish? Yeah, I want to derive debug. And maybe I'm also going to derive debug for our payload. Yeah. Oh no, it just, no, I don't. This is all right. And in the display, we display the header. And then we say self payload format. And it takes F. Oh, we have to disambiguate. Disambiguate method with I need 4. Like that, okay. So, everything's still green? Yeah. Everything's still green. What is the next step? The next step is... I have to make it more similar to our message enum. And that means, so this is all right here. All right, this deserialize is not all right, but maybe we can find usages and inline that. So this is the function, this is the test. Yeah, so this test, I want to rewrite the test so that it works only with the payload struct. So we have a block, network, publish. Yeah, so I want to say publish payload and block and digest. So this should take the block and digest 1, 2, 3. What's wrong here? Option. Oh, it says an option. Then we have a stream. We serialize. We serialize our publish payload. And then we need a header. Header doesn't matter. Let's just say new. Message type. Publish. And protocol and default. And then we say deserialize, publish payload deserialize with the header and so on. And then we say these must be equal. Let's run the tests and see if it still passes. It doesn't. Invalid block type. Line 180. It says invalid block type. Oh, is that in the header? Let's have a look at the deserialize function. Does it use something from the header? Yeah, header block type. Oh, okay, so it uses something from the header. So we have to say... Oh, we have to say header. Set block type. What is the block type? Oh, we can get it from block, I think. Block type. Ah, okay, yeah, the block type is moved. But we know it's a state block. We can just say block type state block. Block type state. Still. Oh, the digest is wrong. Yeah, so the digest, okay, we get the digest here. Okay, that's the bad. All right, green again, green again. So that means, can we delete which one with header? Which one was the thing I wanted to delete? Yeah, and also the new, but let's delete this one. So we want to say publish Header is this is the header. This is the header. Header. And the payload is just header and digest. What is the payload then? Oh, this is the payload. We have to import publish payload. Let's run the tests and see. Green. So no more usages of that function. We can delete that. So what about this deserialize function? I want to delete it too because it still has these publish specific arguments. So just one usage in message deserializer. So here again we can maybe, let me copy that line, maybe we can say publish deserialize or maybe I just rename that one to deserialize publish. Yeah. This is also something that could work well if I just have these, if I just give them the specific names what they deserialize into, and then I can move all of them into the block message enum type. Oh, okay, this is the oh, it's so late already. This is the last giveaway. 1 nano for the last nano goes to oh, this super close. Sergio. News, I'm sorry, but it's just Sergio. That is really close. So 1 nano for Sergio. The last nano. Okay, so I want to commit this now because we're done. Just running the test one more time. And yeah. Yeah, lucky you. Yeah, let's commit this. And what did we do? We worked on the publish. Yeah, so move code from publish message into publish payload. So yeah, so that's, I think I'm going to work on this off stream because now it is always the same. So I'm splitting up the messages, moving all of the code into the publish, into the payload structs. And then I want to merge the top layer, the message level layer into just one struct, into the message struct basically. And going in these small steps is possible, and I think I think it shouldn't be very problematic really. I think this should be just straightforward way to convert all of the messages into an enum type, and yep, just a bit of work. So I think I'm going to work on this off stream. So okay, I think this stream today was a bit dry. So yeah, but I hope you had fun anyways. And I hope you have a good week and a good night. So see you next week, next Tuesday. So from now on, the time has changed because we have winter time now in Germany. So it is 8 p.m. UTC every Tuesday. Guys, have a good one. See you.